we are now convert the this diagram that is flat and without any vertical structure into a multi-channel diagram with a hierarchical structure and with the possibility to share elements between the two different channels. In this application, we have the two inputs of the DT1260 connected to two trigger elements with hysteresis. Each trigger element has an independent threshold and but shared hysteresis. The output of these two trigger elements are connected to an oscilloscope. So on the oscilloscope, we can have the analog tracks. So we can see the input channels, the trigger signal, and the time over threshold. So when the input signal is over the threshold, connected to respectively analog and the two digital input of the two independent oscilloscope. Moreover, the time over threshold is connected to the two LEMOs, LEMO 0 and LEMO 1 of the DT1260, in order to output the when the signal is over the threshold to the LEMO. So on the board, we will create a sort of comparator. If we have a look to the memory organization, we can see that we have the register threshold 1, threshold 2, the hysteresis, and the two oscilloscope mapped at different addresses when we press @sign. Okay, now we want to convert this design in an hierarchical design. We can go here, create a new subdesign, rename the subdesign as my comparator. Okay, and now we can clean this design. Okay, we need just half of the design because the Sci-Compiler will replicate the rest of the design. So delete this register, the trigger, the oscilloscope. And the other part of the design we will move in the new design. So we can just select everything we want to move, not the LEMO, because the IO must stay on the top to avoid collisions between names. And also the trigger hysteresis will leave on the top because we want to share between the two channels. So cut and paste here. Okay, now we have we've moved this part of the circuit. We can now create a new port. So we go in toolbar, MISC, schematic port, and choose an in, and this is our analog input. We have to set the size to 16 and the multi-channel behavior to array, because we want that this parameter is different because it's the input for each a part of my circuit. So I confirm, okay, and I connect this to the data input. Now, the threshold, you see, the register now is inside this design. It's fine because we want two different thresholds for the two channels. So it will be replicated by Sci-Compiler in two registers. Now, the delta, so the hysteresis of the trigger. We can simply create a new port in. It's always been 16, and we call east with y. But this time we select common because this will be shared between the two parts of the design. So we want the same parameter for the two channels, and we connect the hysteresis to delta. Okay, now the output, the TOT. The TOT, we create a new port. We go in MISC, port out, and we call TOT 1 bit, and automatically it will select disable the multi-channel behavior, because for sure when we have an output, each channel should have its own output. So we put this here, put this here. Okay, great. So now we need to set the addresses to the register and the oscilloscope inside the sub page. So we right click on the name of the design, open memory map, press refresh and auto-assign. Now we create the addresses for the two registers, and we assigned the memory 2 kilobytes of memory to this sub page. We go back in our top and we select diagram. Okay, now we need just to place the new component, we go to toolbar, subdesign, multi-channel design. It say, oh, it's out of sync. Yes, because we needed to save the design in order to compile that page. Now we can go back to the subdesign, multi-channel. Okay, it's fine. We can call it comp, and how many times we want, two channels, insert. Okay, this will be the name, the endpoint name will be page comp. Okay, we just arrange the elements near the page comp, and we can connect all together. Okay, move it here and connect the time over threshold and the other time over threshold of the other channels. And we completely convert our flat design in a multi-channel design. If we want, if we use a bigger device like the R5560, we can replicate these to 32, or for bigger devices even more. And so we can just design one time the core of our design, and then replicate all the time we want the design.